Welcome to my YouTube channel Shiv Academy of Mathematics. Myself Dr. Manoj Antil. Today in this video I am going to discuss question number 7b of UPSC CSE Mains Mathematics Exam 2022 from section B. So the statement given was solve the following initial value problem by using Laplace transformation. d2y by dt square minus 3dy by dt plus 2y equal to ht, where ht is given 2 for 0 less than t less than 4, 0 for t greater than 4, and y0 equal to 0, y dash 0 equal to, that is also 0. So this question was of 15 marks. So dear students, when we have to solve any initial value problem by using this technique or this transformation method, Laplace transformation, the steps which we have to follow. First of all, what you do, you will take the Laplace transform of the given differential equation. Just like we are given this differential equation. So in the first step, what we do, we take the Laplace transform of this differential equation. After that, we apply the initial conditions. And just like here, this y is depending on t. When we take the Laplace transform of this y, we get after transformation, suppose y bar s. Then what we do in the next step, we keep the term y bar s in the left side and other terms of s on the right side. And finally, we take the inverse Laplace transform. And after that, we will get the solution. So let us start the solution. The given differential equation is what? It is d2y by dt square minus 3dy by dt plus 2y is equal to h of t. So we take it as 1. And just I discussed in the starting of the video that what we do, we take Laplace transform this one both sides. So next we have written that taking Laplace transform, in short I am writing it is LT of both sides, we get what we get. It is L of d2y by dt square minus 3 times L of dy by dt plus 2 times L of yt is equal to L of ht. And ht is given 2 for 0 less than t less than 4 and 0 for t greater than 4. So what we do, we write it in another way, just like we have written it as L of y double dash t minus 3L of y dash t plus 2L of yt equal to. So we have applied the formula of Laplace transform here. L of ht equal to 0 to infinity integral 0 to infinity e to the power minus st ht dt. So now we apply the Laplace transform of derivatives. It is the Laplace transform of second derivative. So we apply the formula s square y bar s minus s y0 minus y dash 0. So suppose it was L of y triple dash t. So it will start from s cube. So terms will be s cube y bar s minus s square y0 minus s y dash 0 minus y double dash 0. So this is the Laplace transform of derivatives. Then L of y dash t, so we write it as s y bar s minus y0 3 as it is plus 2 times L of yt, we are writing it as y bar s, so it is 2y bar s. And in the right side, what we do, we break this integral into two parts, 0 to 4 and 4 to infinity, because in the statement we have given st in these two parts, 0 to 4 and greater than 4. So that's why in the next step we have break it into parts, integral 0 to 4 e to the power minus st. In 0 to 4 it was 2 and in 4 to infinity it was 0. So we have written here 0, here 2. So the second term becomes 0 because it is 0. So we simplify this integral, we get 2 times e to the power minus st by minus s, limit going from 0 to 4 and plus 0. Plus 0. And in this side, what we are doing, we are applying the conditions y0 and y dash 0 both are 0. So we put this value 0, this value 0, here 0. So finally we are having this term only, s square y bar s minus s into 0 minus 0 minus 3 times s y bar s minus 0 plus 2y bar s is equal to 2 times e to the power minus st by minus s 0 to, it is 0 to 4. So in the left side, we combine the terms of y bar s By chance here all the terms are only of y bar s, so it is s square minus 3s plus 2 s square minus 3s plus 2 y bar s is equal to, so it is minus 2 by s. When we put the upper limit, it is e ki minus 4s. When we put the lower limit, it is 0, so it e to the power 0 is 1, so it is e to the power minus 4s minus 1. So we are having 2 by s into 1 minus e to the power minus 4s. So now I just discussed that we keep this y bar s only in the left side and this term in the right side. So after making changes, what we get? So look at this. Because the left side was s square minus 3s plus 2, so we did the factors. It is s minus 1, s minus 2, y bar s is equal to 2 times 1 minus e ki minus 4s upon s. So y bar s is what? 2 into 1 minus e ki minus 4s by s into s minus 1, s minus 2. So in the numerator we are having two terms, so we separate these two terms. It is 2 into 1, so it is 2 by s, s minus 1, s minus 2. Then it is 2 times e ki minus 4s with the negative sign minus 2 e ki minus 4s upon s into s minus 1, s minus 2. So finally what we do, we take inverse Laplace transform both sides to get this solution. So in the final step we are taking inverse LT both sides we get. So inverse LT of y bar s is equal to 2 times inverse LT of 1 by s, s minus 1, s minus 2 minus 2 times L inverse of e ki minus 4s by s, s minus 1, s minus 2. So you know very well that how we can find the Laplace inverse Laplace transform of this term. So we have to make the partial fractions. So we make the partial fractions of this 1 by s, s minus 1, s minus 2, which is very simple. So all these are the linear terms, not repeated. So we take a by s plus b by s minus 1 plus c by s minus 2. Now we find the values of a, b, c. So we take the LCM s, s minus 1, s minus 2. So finally we are having only this term 1 equal to a into s minus 1, s minus 2 plus b into s, s minus 2 plus c, s into s minus 1. So one by one we put the values. First one it is s equal to 0, then s minus 1 equal to 0, s minus 2 equal to 0. That means to say we are putting s equal to 0, s equal to 1, s equal to 2. So when we put s equal to 0, we are having left side as 1. It is a into minus 1 into minus 2, so 2a equal to 1, that's why a is equal to 1 by 2. Similarly, when we put s equal to 1, we get the value of b, which is minus 1. When we put the value of s equal to 2, so we get the value of c, which is again 1 by 2. So finally we put all these three values in this 1 by s, s minus 1, s minus 2, a plus b plus c. A is 1 by 2, so it is 1 by 2s. It is minus 1 by s minus 1, it is 1 by 2 s minus 2. So when we put these values, so we compute this inverse Laplace transform. So it is L inverse of 1 by 2 into 1 by s minus 1 by s minus 1 plus 1 by 2 1 by s minus 2. So this L inverse of 1 by s is 1 because we know L of 1 is 1 by s. That's why we can say that L inverse of 1 by s is 1. Similarly, we apply the formula from this Laplace transforms. L of e to the power at is 1 by s minus a. That's why we can say that L inverse of 1 upon s minus a is equal to e to the power at. So the inverse Laplace transform of this it is 1 by 2 into 1 by s, so it is 1. L inverse of 1 by s minus 1 is e to the power t, and L inverse of 1 by s minus 2 is e to the power 2t. 1 by 2 as it is. So dear students, if you look at this 2, the first term we have solved this inverse Laplace transform, the first term. Now the question is how we find the inverse Laplace transform of this e ki minus 4s by s, s minus 1, s minus 2. So to solve this part, we have to apply second shifting property. I have written here that if L inverse of fs is equal to ft, then L inverse of e to the power minus as fs is equal to ft minus a ut minus a. This u is what known as the unit step function, which I have written in the definition of this unit step function also. So to compute this second term, or to evaluate this inverse Laplace transform in the second term, that's why we have taken this as ft. Because in the second part, the term with this e ki minus 4s is 1 upon s minus 1 s minus 2. So in the final step, what we are doing, so look at the top. Again I am writing L inverse of 1 by s minus 1 s minus 2 is 1 by 2 minus e ki t plus e ki 2t by 2, which I have taken ft. So we apply the second shifting property. So it is L inverse of e ki power minus 4s into 1 upon s minus 1 s minus 2 is what? Because that was ft minus a ut minus a is 4. So it is ft minus 4 into ut minus 4. So this is what our ft. So we replace t by t minus 4 here to get this value of ft minus 4. So when we put t is equal to t minus 4, so we are having this as 1 by 2 minus e to the power t minus 4 plus e to the power 2 t minus 4 by 2 into ut minus 4 as it is. So we put the value of this 4 and 5 in 2. So using 4 and 5 in 2, what was 4? So look at this. This is what our 4, the inverse Laplace transform, that is the first term. So when we put these two values, 4 and 5 we are using in 2, so what we get? L inverse of y bar s is yt, and it is 2 times 1 by 2 minus e ki t plus 1 by 2 e ki power 2t minus 2 times this whole term, 1 by 2 minus e to the power t minus 4 plus 1 by 2 e to the power 2 times t minus 4 into ut minus 4. So we multiply this 2 in this and here also. So it is 2 into 1 by 2 is 1, 2 e to the power t, 2 cancel out, so it is e to the power 2t. Minus again 2 cancel out, so it is 1 minus 2 times e to the power t minus 4 plus e to the power 2t minus 4 into ut minus 4. So this is what our answer of this initial value problem. So all the steps which we have followed, first of all what you do, you will take Laplace transform of the given differential equation, then you apply the initial conditions. After that you keep y bar s on one side, other terms on the right side. Finally you take the inverse Laplace transform and you will get the solution. So just I told you that what was ut minus a. Ut minus a is basically called the unit step function or Heaviside unit step function, and its values are ut minus a is 0 for t less than a, 1 for t greater than equal to a, where a is non-negative. So this was unit step function which we have used in the second part. So dear students, hope so you understand this problem and try to solve such kind of problems, initial value problems for your UPSC mains exam of mathematics. Because a lot of times in UPSC exam, the question based on this Laplace transform is asked. So keep enjoying and watching our videos. Don't forget to subscribe our YouTube channel Shiv Academy of Mathematics, and if you like our video, then don't forget to like our videos. And also if you can share to your friends who are preparing for UPSC mains examination and they have opted mathematics as their favorite subject, so you can share this video to your friends also. Thank you. Have a nice day.